Welcome to our video lesson over operations with radicals. Before going through this video and learning this skill, you definitely need to be sure that you are familiar and comfortable with simplifying radicals, which we covered in the previous two sections. Let's get started. The operations are, of course, adding, subtracting, multiplying, and dividing, and this video will focus on those first three. First, we need to understand when we can and cannot combine, meaning just add or subtract, radical terms. They have to actually be like terms. So in number one, we see that we want to find a sum or difference. Here we're subtracting. We're going to find the difference between 3 root 6 and 2 root 6. Note that these terms both have a root 6 in them. That means that they are like terms. They are like radical terms because they have the same radicand or expression under the root of 6. So we have 3 root 6s minus 2 root 6s. That means we're left with 1 root 6 remaining. We, of course, do not need that 1 out front, so we can simply write this answer as the square root of 6. All done. Let's take a look at number 2. Here we want to simplify 2 root 5 plus 2 root 5. Are these like terms? Yes. They have a 5 under the radical, and they both have the same value under the radical. So we have 2 root 5s plus another 2 root 5s. How many total root 5s do we have? We have 4 of them. And there we go. Here we just have 3 terms, all with radicals, and again, we want to simplify. So we have 3 terms here, negative 2 root 10, positive 3 root 6, and negative 2 root 10. 2 of them are like the ones with the same root or radicand. We have a negative 2 root 10 and another negative 2 root 10. Next, we have an individual term. It does not have any terms that are like it, 3 root 6. So that is not going to be able to be combined with the other 2. However, our terms underlined in double blue, we can combine. Negative 2 root 10 and another negative 2 root 10 combined to give us negative 4 root 10s. Next, we're going to add on that plus 3 root 6. And when I say add it on, we're just going to do plus the term because we actually cannot combine those. They do not have the same radicand or number under the root. And that is our final expression simplified. Here we're again going to find the sum or the difference. Here we do need to be sure that we understand how to simplify radicals. So in number 3, we see that we have 10 root 7 plus 2 root 63. These are not like radicals, but if we simplify the root 63, we will see that we do actually get a term with root 7 in it, and we'll have like terms. So we can see that our first term is unable to be simplified. The square root of 7 cannot be simplified any further. Then we want to add on this 2 root 63. Well, to break down the square root of 63, we'll break down that root as root 9 times root 7. 9 times 7 is 63. And continuing on just on that blue term here, we're going to have 2 times, I was thinking ahead here, square root of 9, which is 3 root 7. That term will simplify to 6 root 7. So we actually see that we actually do have like terms. We have 10 root 7 plus 6 root 7. How many root 7s do we have total? We have 16 of them. So combining these now like terms, we'll get 16 root 7. Let's take a look at problem number 4. We see that we have the square root of 15 minus 6 root 60. The square root of 15 cannot be broken down any further. There are no perfect square factors of 15 other than 1. Then 60 can actually be broken down, or root 60 rather. So we have minus 6. Then let's break down the square root of 60. The biggest perfect square that fits into 60 is 4. So we're going to have root 4. 4 times what is 60? 15. Then when we simplify this term in red here, we'll have 6 times 2 root 15, which will give us ultimately the term minus 12 root 15. That first term is just going to come all the way down here. Now, how many root 15s is this term here on the left? It is only one of them. We can put a 1 out front if we need to help us. We now see that we have two terms that are like. They have the same radicand of 15. We have 1 root 15 minus 12 root 15s. How many root 15s do we have left? 1 minus 12 is negative 11. So this term simplified as negative 11 root 15. Here we're again doing the same thing, but now both of our terms are going to be able to be broken down. In number 5, we see that we have 2 root 32 minus 3 root 18. Let's break down this first term in green. The square root of 32 can be broken down into the square root of 16 times the square root of 2. I'm going to keep working on this term here. The square root of 16 is 4. So we have 2 times 4 times root 2. 2 times 4, 8, root 2. If you need to write down each step, that's totally fine. I'm just trying to do some in our head here. All right, let's take a look at our second term here. It's minus 3 times root 18. Root 18 gets broken down as the square root of 9 times the square root of 2. Working ahead, we see that the square root of 9 is 3. So we have that original 3 times that 3 to get 9, and then we have a square root of 2. Note that now we have like terms. They both have a root 2 in them. So we have 8 root 2 minus 9 root 2. 8 minus 9, that's negative 1 root 2. And of course, we do not need to write the 1 out in front, but that negative is important. So negative root 2. In problem number 6, we have a very similar type of situation here. So let's go ahead and break down both of these. We have a root 28 and we have a root 112. If you need to do this, go ahead and pause now and see how you do, and then you can check your answer. I will work through here. So negative 4 root 28. The square root of 28 can be broken down as root 4 root 7. So this is going to give us negative 4 times the square root of 4, which is 2. I'm actually writing this one more steps out here. So we have negative 8 root 7. That's our first term. Okay, now this second term. This number is a little bit bigger, 112. Here's kind of a hint. We know that we're probably going to want a 7 in there when we break it down, when we break down 112. So I'm actually going to divide 112 by 7. I know it's an old school calculator. What even is this? 112 divided by 7. And I did end up getting 16. So root 112 can be broken down as root 16 times root 7. Okay, next up, root 16 is 4. And so we'll get 16 root 7 for that term. Finally, our last line, we see that we actually have two terms that are like. They have the same radicand of 7. So we have negative 8 root 7 plus 16 root 7, which gives us positive 8 root 7. Negative 8 plus 16. And there we have it. Next up, we're going to be multiplying some radicals. Math is radical. Let's go ahead and find the product. That word product means to multiply. So, and a cool idea before we actually get into this is just understanding how radicals kind of work and the rules. And I know we did go over this already, but just in case you missed it, if we have the square root of a times the square root of b, right, we can just multiply straight under the root there. So we end up getting the square root of a times b. And that's legal. So that's the main rule we're going to be utilizing here. Values that are under the square root, we multiply them and they all go under a square root together. Values that are outside of a root, just plain old numbers, they get multiplied together. Now, before we can do this in a couple ways. So let's actually take a look at number 1. We have the square root of 8 times negative the square root of 3. So I'm going to put a 1 out in front of this 8 here. So we have 1 root 8 times negative 3 root 2. the values that are outside of the root are going to get multiplied together. So 1 times that -3. Then the values that are under our root get multiplied together as well using this rule up here. So we have the square root of 8 times the square root of 2. 8 times 2, that gives us the square root of 16. Now from here, I recommend simplifying. Now we could have simplified first, but in this case, I saw we were going to get a 16 under the root, which is nice because that's a perfect square. So the square root of 16 becomes just a plain old 4. So we end up having -3 times a 4, and that will give us -12. So this problem actually kind of broke out of a root. We don't even have a root in our answer. Okay, let's take a look at number 2. What numbers are out front of the root? What are the coefficients of each term? We have a 1 root 3 times a -1 root 2. So 1 times -1. That means I'm just going to have a -1 out in front. Then I have my root 3 times root 2. 3 times 2. That goes under the root. Can we simplify the square root of 6? No. We just don't need to write that negative there, so we can write this as negative square root 6. Done. Okay, some more multiplying radicals, just getting a little more challenging, but actually more fun. So let's again see if we can actually kind of break down first or simplify the roots first. We can see that these numbers under the root here are just getting bigger. And so when we multiply the numbers under the root, 10 times 12, that's a square root of 120, and you'll have to simplify that. How about we try to simplify first instead? Now, 5 root 10, root 10 cannot get simplified, but 12 can. So let's actually break down the square root of 12. It's going to end up being the square root of 4 times the square root of 3. And I didn't mean to make that look like a minus there. Sorry, this is a whole times thing here. This is times -7 root 4 root 3. Okay, so we have 5 root 10 times, then this square root of 4 here is a 2. So we have a -7 times a 2. -14, and we still have the root 3. So this is the problem I'm doing. I'm doing 5 root 10 times -14 root 3. So now we can multiply the numbers out front. Yes, I'm using a calculator for 5 times -14. It's -70. Then I'm going to multiply my values under the root. Square root of 10 times the square root of 3 is the square root of 30. Now, I know we already simplified, but sometimes at the very end, we might have to simplify again because these numbers just keep getting multiplied. They get bigger and bigger. So the square root of 30, can that be simplified? No, there is not a perfect square factor of 30. It's not divisible by 4, 9, 16, or 25. All the possibilities less than it. So -70 square root 30 is our answer. All right, looking at problem number 4, we're going to do the same thing. So let's break down the square root of 8 because the square root of 14 can't get broken down. The square root of 8 gets broken down as root 4, root 2. So we have -4 root 14 times the square root of 4 again is 2. So we have 2 times 2. That's a 4 root 2. Okay, so now our problem is -4 root 14 times 4 root 2. Let's multiply our coefficients, our numbers outside of the root, out front. We have -4 times 4, -16. Then under our roots, we have a 14 and a 2. So we're going to have root 14 times 2. So we have root 28. Now, before I square this answer or circle it and say this is the final one, we need to ensure that the square root of 28 cannot be broken down. Think, can we simplify the square root of 28? Yeah. It breaks down into the square root of 4 times the square root of 7. So we have that negative 16 out front. The square root of 4 is 2. The square root of 7 is, just the square root of 7. And we have a negative 16 times, and run out of room here, negative 16 times 2. So we'll have negative 32 square root 7. So these can sometimes take a little bit longer, just depending on the numbers that we have. But it's always a good call to simplify first, especially if you see those numbers under the roots are going to give you some big root. Could you do this in an alternate way? Yeah, in math, there's always multiple paths to get to that one answer. I just like to keep the numbers as small as possible while working to be slightly less intimidating of a topic. Okay, let's multiply here. We just got 3 terms being multiplied to give us our final product. These numbers are going to be really big. Like if you multiply 32 times 27 times 2, this is what you would have to do if you did this. You would have to simplify the square root of 1,728. Like I don't want to do that. So that's not how we're going to do this problem. We're going to simplify first, then multiply, because this is a big number. So let's break down the square root of 32 first. We'll get root 16 times root 2. Awesome. I'm just going to go down and keep doing that in blue there. So we'll get a 4 root 2. Okay, now let's break down 27, root 27. So we'll get square root of 9 times the square root of 3. Square root of 9 is 3. So this breaks down into 3 root 3. Of course, we're still multiplying these terms. That last term we can't do anything with it. So I'm just gonna, it's just chilling as root 2. There we go. And now we just have a much less intimidating problem where we're just gonna multiply all of our values out front and then multiply all of our values inside the root. So let's do the first thing and get this 4 times this 3, and then there's just a 1 in front of the root 2. So 4 times 3. Then we're going to multiply under all our values under the root. So we'll get root 2 times root 3 times root 2. So 2 times 3 times 2 is 12. So we end up having the square root of 12, and that can get broken down. The square root of 12 breaks down into 4, root 3. We still had that 12 out front. So this ends up being 12 times 2 times root 3. And we get 12 times 2, 24 square root 3. Our final problem, just kidding, not our final problem. Our third to last problem, we're going to break down. So root 5 can't be. Root 24 will break down into root 4 times root 6. Root 4 is 2. So 2 square root 6. And then root 75 can be broken down to root 25, root 3. So root 25 is 5. So 5 root 3. Okay, did a little bit in my head there. All right, multiplying our numbers out front. A 1, a 2, and a 5. So multiplied give us 10. Then our numbers under the root, root 5, root 6, root 3. All right, it's going to be big. 5 times 6, that's 30, times 3, 90. So we have root 90. Can root 90 be simplified? Yes. The square root of 90 can be simplified as the square root of 9 times the square root of 10. So that 10 out front stays. That square root of 9 is really a 3. So we end up with 30 square root 10. And lastly, these are our last problems. I forgot about the variables here. So we are going to be working with variables as well. I am just going to do the variables kind of in just a straight up multiplication way and simplify them at the end. I think that's the simplest way to deal with variables. Let's take a look at 14 and 6 here in problem number 7. We can see that we are multiplying the square root of 14r squared, the square root of 6r to the 7th. All right. So let's deal with just the numbers. So I'm going to deal with just root 14 and just root 6. And then I'm going to deal with the variables separately as the square root of r squared times the square root of r to the 7th. You by no means have to break it up like this, but you can if it's easier for your brain. So root 14 times root 6, I'm going to go ahead and just multiply 14 by 6. We get 84. So this is root 84, and then we can probably break that down. So let's actually do that. Let's break down the square root of 84. I can't even remember what it is. I think it's just 4. Maybe it's not. Oh, yeah, it is. 84 divided by 4 is 21. Okay, all right. So we got root 4 and root 21. Square root of 4 is 2. It's kind of old news, hopefully, by now. There we go. Okay, so that's what we have there. Now let's take a look at our variables. So I'm just going to multiply this to give us r to the 9th. Right? Recall that when we're multiplying with the same base, r here, we add those exponents together. So this is the square root of r to the 9th. And then we can break that down like we've seen. So this is an odd power. 9 is odd. So we're going to break this down into the square root of r to the 8th times the square root of r to the 1st. I don't need to write the 1. The square root of r to the 8th is we take half of the exponent. So that's r to the 4th power. And then we still have a root r. Now, how do we write our final answer? How do I relate these two things, right? I broke them up for my problem, but I need to put them back together to give a final answer. So what we're going to do is we're going to put everything that's out front. So that 2 and that r to the 4th are part of our outside the root term. And then underneath the root, we have the 21 times the r. So there we go. Okay, our last problem today is very similar, but these numbers get a little bit bigger, but let's just see how these numbers can kind of work out nice, essentially. So I'm going to sort of break this into, I guess, 3 parts because we have values out front now. So let's just deal with that to start. So it looks like that -5 times that 2, we're just going to have a -10 that we'll deal with. Okay, now let's take a look under the root. So let's look at our just numbers under the root. We have a root 2 times a root 32. And then we can deal with the variables on their own. So we'll have root m to the 6th from that first term and the square root of m squared for that second term. Okay, so that -10, I'm just going to let it kind of stay out front. Now, how about 2 and 32 when we multiply? We get something nice. We get the square root of 64. So I'm going to multiply first because that's a perfect square. So we don't need to simplify and all that first. Let's multiply first. 64 is a good number to take a square root of. Now over here, we have the square root of m to the 6th times m to the 2nd. What's that going to give us in our exponent? An 8. We add. All right, now simplifying, we have -10. We have times that 8 here. We have times that the square root of m to the 8th. Remember, we take half when we're taking the square root of those variables and exponents. So it's m to the 4th. We divide that exponent by 2, take half of it. Simplifying here for our final answer, we'll get -80 m to the 4th. This one could completely come out of the roots. All right, nice job today. Thank you for going along this journey. It was pretty radical.